let's take a look at the chemical reactions, which are peculiar to aldehydes and ketones, right? So as you may guess, so we are just going to pay attention to carbonyl group once again, because it's been quite a star in this chapter. So yeah, basically what happens is that carbonyl addition reactions can take place, right? So basically you need to focus on the CO group, right, or the carbonyl group, so where the reaction is going to take place, the addition reaction. So we can take a look at some examples, right? So maybe we have some sort of R group here, R group there, right? So maybe you have, let's say, methyl here, and here you have H, or you have here an ethyl, right? So the point is that, so once the addition reaction happens, you chiefly need to think about the bond breaking and making in this region, right? So those ones just stay intact normally, right? So now let's take a look at some examples. What can we do, right? So we can do the so-called reduction of aldehydes or ketones. They will go in a very similar way, right? But the products will be different, right? Of course, because we have different substrates. So now let's add H, right? So we're going to add H. We'll show the bond, which will be broken, right? So this reaction, the reduction reaction or the addition of hydrogen, in other words, will have to take place in the presence of platinum. Platinum is the catalyst that makes the reaction go faster. Otherwise, it will just not go, right? Or go fast on a geological scale, and it will take millions of years to complete, right? So then the bottom line is that we're going to break this bond and we're going to break that bond. So we'll liberate electrons upon the bond breaking. So now you need to connect the electrons to make new molecule, right? So basically you're going to add two H's to the original molecule, which could be either aldehyde if this is H, right? Or a ketone if this is some sort of alkyl substituent. So the overall general example will be like this. So retain your R and R double prime. So retain one bond between C and O, because only one is broken out of the two, right, in this double bond. So then you'll have your liberated electrons, like so, and then put the H's with the liberated electrons next to the liberated electrons from your original organic molecule, right? Connect. You see, you make an OH group, right? So that's what will happen in all the basically aldehydes or ketones upon this reaction, right? And you will have a CH bond, which will also happen in all the aldehydes and ketones upon this reaction execution. Done. This is your new bonds. Those fat ones. All right, so that's it. That's your stuff, right? So, and then speaking of the previous things and reviewing previous things, if you have, let's say, methyl and ethyl here, you are going to make the secondary alcohol. So reduction of ketones gives secondary alcohols. If you have here, let's say, methyl, and here you have an H, right? Then you are going to make what? A primary alcohol. So in other words, reduction of aldehydes yields primary alcohols. Where there is reduction, there is oxidation, right? So if we take a look at ketones, turns out ketones in the presence of mild or even strong oxidizing agent cannot be oxidized, right? But aldehydes can be oxidized. Let's say we're going to have some kind of aldehydes, which is going to be looking like this, methyl with a COH, right? And we're going to oxidize it. So typically, oxidation happens in the presence of the strong oxidizing agent, SOA, right? So, and then these are your conditions, can be shown typically under or above the reaction arrow, by the way, right? So, and then you are going to show the oxidation product. Methyl prevails. Then your aldehyde will turn into the carboxylic acid functional group, which you saw in the past. And we'll be talking about this more in detail later. So you see oxidation happened. So that's true to the definition of oxidation. So according to which you can experience the increase in the number of oxygen atoms. 1 to 2. Okay, all set. So we made it. So basically, So if you will, for the ease of understanding, for now, just kind of like inject the oxygen atom in between carbon and H, right? So that's what you're going to have. Couple new bonds. So that's your injected oxygen atom right there. So that's what the carboxylic acid looks like. And then if you just remember somehow, right? So from our initial videos, when we were just talking about broadly functional groups, then you will recall that this is a functional group called carboxylic acid, right? And then it is typically attached to another carbon right here, right? So some sort of like carbon atom. So typically alkyl chain follows, right? So again, some complications are possible, right? So, but if you look at this, so COH attached to something, so that's going to be the carboxylic acid functional group. And together, this is going to be the carboxylic acid compound, right? So in this case, by the way, coincidentally, we synthesize the carboxylic acid that can be found in like many household applications, for example, in white vinegar. So this is going to be known as acetic acid. Acetic acid formula is this one. So that is as far as the oxidation is concerned. So now we are moving on to more specialized topics, right? So we are going to look at like further reactions of aldehydes, right? And ketones when they react with alcohols, right? So that's going to be maybe the most complicated type of reactions, right? Because in this case, we are going to react at this point for the first time, I would say, right? So far, the organic molecule with another organic molecule, right? Well, typically, like actually in the past, we were looking at the reaction between one alcohol and another alcohol. So yeah, it's not new. So, but anyway, so here we're going to take a look at the like another reaction type, which is going to be the condensation as well, right? So, which is not new at this point, but we're going to condense not two alcohols, for example, of the same or different natures, but we're going to condense aldehyde and one molecule of alcohol and then another molecule of alcohol, right? So it's going to be kind of the step-by-step synthesis chain, as they call it, right? So because in this case, we're going to have two consecutive steps. So typically a chain of the like reactions is going to be like this, like A, right? So reacts with something, right? And then it makes B. Then B reacts with like something else, some kind of delta 2 conditions, right? And then you make C, right? So that's what, then you can continue, right? You can apply like maybe some kind of delta 3 conditions, make like compound D and so on. That's what the synthetic chain is about, if you were to describe it in like very simple terms, right? And of course, we are going to kind of populate those like deltas and the letters with more complicated things. So such as like specific conditions, right? And some sort of complicated organic molecules. So that's going to be the point here.